Hello guys, this is a 2007 Kia Rondo 2.7 liter engine. I had a complaint where the car is overheating, and the first thing that I do, I always check the coolant level. It was low. I found a leak on the two hoses that leads to the heater core. One clamp was loose and the hose was slipped off a little bit, so I took care of that, took the car for a test drive. It was running fine for a good 20 minutes, and then the temperature started going up over the kind of midline, and it would go back down again. It started acting up on me, and so when I talked to the lady that owns this car, she told me that once she noticed that cooling fans did not work, and to be honest, I wasn't really concerned too much of if the fans are working or not, because when she came in, I simply turned the AC on and the fan kicked right in, and I said, well, this is not issue with the cooling fans, it's a coolant leak. And so then after I fixed the coolant leak, it started acting up a little strange, and I was thinking maybe it's a problem with the thermostat, and I said, well, let's go ahead and check the operation of a cooling fans. And I got my snap-on wires, and I do not have a bi-directional control to turn the fan on. And there's basically the high speed and low speed. It's a pretty simple diagram. I know this is a bad picture, but this is the high and low speed relays. How we located these two guys, and we have two relays, and one will give the power to the fan on this red wire on the low speed, and it goes over the low side relay, and the high side relay is going to, of course, give the power to the white wire, and the fan will blow full speed. The low side gives the full power, full 12 volts or 13 volts, whatever the system voltage is, but it's going over the resistor. It's going to lower internally. It's going to lower the voltage, and the fan is going to spin slower. Now let's go ahead and test the, since I did hear that my fans, working, I know my fuses are okay, because the same fuses will feed both of these relays. This is a high speed. This is a high speed. This is a low speed relay. I'll take the relay out. So the one fuse is the load side is hot all the time. The control side is hot with a key on. And now I got a key on already. Unfortunately, as I said, I don't have the wiring diagram. I'm sorry, the bi-directional control that I can control my relays. So I'll just have to do it manually. So I have my test light connected to battery ground. I'm looking for 2 feeds, and now this is what I have done to my adapters. You guys have seen this before. I have a red and black wire. It's on the control side, green and blue is on the load side. So I don't have to look for pins and trying to figure out what's what. Now on this one is a little bit easier. I can actually go right in, but let's see. So this doesn't light up. So the red one is a power on my control side, and see the green one is power on the load side. Alright, so there's nothing here. Let's go ahead and put the relay in. Let's see the so I'm going to activate my relay by giving a ground to a black wire. Basically this is a ground side switch, because it has a power all the time. Ground side switch circuit, and so the PCM basically provides the ground to turn the relay on. And let's go ahead and you can see the fan is working. All right. Okay, let's move to the low side. Low speed relay. Okay, let's see, it should be power here again. There you go, we got a power on the load side and power on a feed side of the relay. And so I'm going to put the relay in. So we're going to give the ground to this black wire, and that should activate my relay. And it does. I can hear the relay clicking. Let me turn the fan on here. Not off. Now guys, it's too noisy. The shop is too noisy right now. It's like 95 degrees. It's crazy how high it is in September in Kentucky. Okay, so I'm giving a ground, and I'm activating my relay, but there's nothing going on here. Fan is not working. The low side is not working. The next step is to check to make sure that relays, even though it's clicking, it doesn't mean it's low. It's closing the circuit. So let's go ahead and take another test light. I'm gonna connect this one to ground as well. And now we're gonna look if the other side of the relay, the other load side. So let's say we got a power here, and I could get the test light to this side of it. And when I give the ground here and activate the relay, if relay is closing, this test light is gonna light up, and you can see it does. But no action from the relay. Alright, so next step is to get down to a connector, which is here. And you can see somebody was here before. Okay, I got the connector exposed. Now we can see the black wire, that's my ground, and then white and red. The red is, low speed, and white is a high speed. Okay, and now we're gonna get the just gonna use the test light to see what's going on here for now. And okay, I take the test light. So let's actually use this one, and okay, so the relay is closed. Now let's see if we have power to a red wire. Just going to kind of touch it from the side, and we do. Okay. Okay. Okay, let's go ahead and take a load tester. I don't expect to see some kind of voltage drop on this harness, but we'll load test the circuit. I use this fan motor that I salvaged from another project I was working on, and so basically this is just the fan motor. One that I think one of the speeds doesn't work on this one either. So anyhow, let's go ahead and plug it into the harness, and then we'll check it. So let's get the one wire on the ground, one wire on the red wire, so black and red, and then go ahead and activate the relay. There we go. Alright. Okay, so it's working fine. Okay, let's just see how much amps we're pulling here. 2.5 amps. Oh, we have to start the car. Maybe the battery is a little low. gonna use a mil max scale to see what's the maximum amperage on it. Okay, it was pulling 10.8 volts, I mean amps, so that's fine. It's just reversed. So 10 amps, that's plenty of current for this circuit to work. So well, you can see anyway that fan is working. Okay, so at this point we're going to order the fan and fix this problem. Alright guys, we'll continue with the new fan. Well, I guess one of these days I'm going to learn how to read the wiring diagram. This is not internal resistor, it's external, and the fan is okay. So now when I looked at the diagram again, I was like, no, wait a minute, something doesn't make any sense here. And I mean, I misdiagnosed for sure. I was, called for a cooling fan. So the fan is okay because, if it works on this design, if it works on a high speed, it's going to work on the low speed as well. I mean, it's fine. So now this is a resistor, and I got two wires, and basically we're going to get the power on one wire going to the resistor, and the power going to go back into the fan. And I have my relay already activated, so let's go ahead and take the test light, connect to ground. Hope this is a good ground. Let's see, then I'm going to back for one wire. Okay, nothing on this one. Let's see this one here. There you go. So the power comes into the resistor, but it's not coming out of the resistor. So the resistor is basically open. Okay, I got the there's a little crust in there, but it's no corrosion, just some kind of sand or something. And I mean, it looks okay. There's no excessive heat or anything like that, so that's fine. The connector is fine. So my test light is still connected to battery ground, and when I touch this wire, you see it lights up, and this one is actually goes to the fan. Now if I connect my test light to this wire here, that's going to provide me a power, and then if I touch this side of the circuit, the fan should provide a ground, and my test light should light. So it's going to stay, I hope. Okay, so I'm on the power side here, and my fan should provide the ground. There you go. And it says wiring is okay, I just need the resistor. Alright, let's get order resistor instead of cooling fan and fix it. Sorted! Alright, this is like 5-6 days later. I was able to find a original resistor from eBay, and part number is 25385 2E000, made in Korea, and it was like 30 something dollars, 36, 37 bucks. And I'm gonna install this. You just connect your connector and pop it into the fan shroud, and then we're going to redo the test again. Now what I have found, another leak, basically the same leak, same problem I had before. My hose, my clamp was still loose, and I had to tighten it down again, and now I'm holding up pressure pretty good actually. It's been almost like good 10 minutes, and I don't see any, the gauge stayed at the same, so no more leaks. I'm gonna put this resistor and check the low side on the cooling fan. Okay, so let's go ahead and check the cooling fan. I got the resistor installed. So many of you guys asked me about the this adapter for relay testing, and this is just regular adapter, what you buy of the Lyle's or something, I can't pronounce it, but all I did, I just solder these wires, because it's always a pain to identify your load and control side of the relay. So I just actually modify all of them. They come in like 4 in a kit, and I put my red and black on the control side and green and blue on the load side. Why did I choose those wires? Like kind of red and black kind of makes sense to me, you know, positive and negative. And I mean, these two, the blue and green, is something I had, you know, available. But this helps so much, you know, to me anyway. So anyhow, so let's go ahead and so anyhow, nothing really special. Just you know, I soldered the wires to a regular adapters. You can get the kit for 50-60 bucks, I believe. And you know, you want to make sure you're gonna. I put a female adapters on it, but banana adapters, but you're gonna make sure they're insulated, because if they're not, you're gonna cook something. So you gotta make sure these are insulated, because if you know, touch ground on with your like if the computer provides the power to a control side of the relay, and your ground is, you know, exposed, and you touch it, and it can cook the transistor in a module. So to make sure you also good insulation around your banana adapters. So I'm going to pull this relay out and just pop this in. And I think the black wire was controlled, if I'm remembering well. So okay, turn the key on and let's see if it works. Just like when I connect it to ground, because computer is providing the ground to turn this relay on. It's a ground side switch circuit, and okay, there. Lights. I think it's a black one. It's working. See if I can get a piece. I'm sure the camera was able to pick up the. Because it's not spinning the full speed, of course. Now it's not as loud as a. All right. Let's go ahead and check the high speed. We know it works, but might as well do it again. Now, of course, I can't check the my driver. I don't have bidirectional controls, but I think it's working fine. Okay, that's it. Well, this is a good example how you can actually mess things up if you don't pay attention to your wiring diagram. I assume, and you never assume, that, you know, this motor has a resistor built in, like one that I worked on. I had made a video, I think it was Chrysler, I believe. It was a Chrysler Sebring that had an internal resistor built into a cooling fan, and the low speed didn't work and a high did. And on this one, it's a different wire. It's wired different. It has the separate resistor for the low speed. And honestly, I actually called the AutoZone and the local suppliers to see if anybody has the cooling fan. I was going to order one. And well, you know, sometimes you win, sometimes you lose. You just have to kind of check again yourself, and well, it's fixed anyway. So, all right, guys. Thank you so much, and see you next time. Thank you. Bye bye.